Today I'm going to be talking to you a little bit about nighttime burning. I'm a postdoc fellow at the University of Alberta with Mike Flanagan and Piyush Jain. Firefighters are lately starting to report that fires are burning deeper into the night and also are starting to burn earlier in the morning. Well, usually what happens is that at night the temperatures drop and the humidity environment increases. This gives the firefighters the opportunity to rest, reorganize, and plan their actions for the next days. But they're under a new world of climate change and increased temperatures. This will most likely change. In fact, in Alberta, such an episode happened on May of 2019. On the 18th, fires SWF 49 and 50 were spotted along Highway 754. In the next days, fire 50 was controlled, but by May 29, fire 49 was still running, and changing weather conditions in the afternoon that translated to increased aridity caused a night run that burned nearly 100,000 hectares. Given these circumstances, there is increased interest to research the effects of nighttime burning and what is happening. The FWI system assumes that at night temperatures will decrease and the humidity and on the environment will increase, enabling firefighters to regroup. But well, the question right now is if the nighttime fire, under the assumptions of climate change and if nighttime fire weather conditions will become more severe, but also if extreme daytime conditions influence also nighttime burning. To this, we decided to analyze, to start doing a research with hourly weather data from a global reanalysis, and also with this, the ERA5 data set, and also the historical data, the CRU data set. What we did is, what we are doing is analyzing trends over hourly trends for the nighttime weather conditions for the FFMC, starting with the ERA5 data set for the period 1979 to 2020, and with the CRU data set, we can use go back to 1950. Additionally, we are using satellite data for detection and characterization of fire spots. For this, we are using the satellites, the GOES 16 and 17, also known as GOES West and East. So let's start with the extreme daytime conditions. In this example, in the graph we're seeing for the Macmillan fire, we actually calculated the daily FWI for the period of 1979 to 2020, and we calculated extreme statistics of extreme values. In this case, the 95th percentile. We see that in the maps, we actually see these values to the right, and on the maps to the left, we see that the areas in red are the days and the areas that during those days exceeded these values over the 95th percentile. So we can see, for example, on the 29th, pretty much almost all of Alberta was under extreme conditions of fire weather that exceeded the historical values. Additionally, we are looking at the behavior of the FFMC. This is the example for the Macmillan fire. we can see that for the morning from the nights of the 29 and the 30, the values exceeded were way over 90 and dropping only on the early hours of the morning. The red dots we see in this graph are actually satellite detected hotspots that were obtained with the satellites. We can also see we're starting to analyze the. This is just an example of what we're doing. Also the weather behavior of the variables, and we can see that the humidity on the environment dropped drastically on the 29, but there was also an increased wind activity on those days. So, but the overall question behind this kind of events, if there is any difference in the rate at which nights and days are warm enough. There are now starting to appear some studies that are looking into this, but some of them are going this a little too generalizing and on a very broad scale. So using the ERF5 dataset, we started analyzing the minimum temperature. We're starting to look at the trends and the change by year. In this case, the month of May, that is a very important month in terms of fire for Alberta. And we can see that there are certainly, in fact, over all the world, there seems to be that there's an increase on the nighttime temperature. Here we can see the actual values, not only for the ERF5 dataset, but also for the CRU datasets. But when we compare them with the maximum temperature that can be used as a proxy for the daytime temperatures and the minimum as a proxy for the nighttime, we can see actually that there is not really that much of a difference, at least for North America. Now with the CRU dataset, we can go back a little bit more to the 1950s. Now that we saw that there is consistency between the two datasets. We can see actually that there is, with this data set, we can see that there is really, at least for North America, there is not that much of a difference in the way the changes are happening between days or night. I mean, there is definitely increase in both times, but it seems like none is really changing more than the other. We're also looking at trends at the nighttime fire weather indices. For example, for the FFMC, in this map we can see the changes in the max value for every night for a fire season. For the fire season, in the case of the Northern Hemisphere, North America usually involves the months starting from May until around September. I have to also say that under this project, there is also a PhD student from China, Kaiwi's work. This is Kaiwi's. This is some of the things that he's been doing. We can see that, for example, there's definitely a difference in the values when the night is detected with when there is an active fire and when there is not an active fire. We can see that there is definitely different in the on active nights, there is lower humidity and increased temperatures. This is both shown for the springs, for the forest, for the boreal forests and the prairie regions, for example, of Canada. So on the summary of our preliminary results, temperatures are rising, which will increase fire weather severely, but seems like there is no difference, at least that we can see right now in the warming between the night and the day, at least for the month of May. We also have done all these calculations for other months, and they all seem to be on the same, on similar. We see that there has been an increase on the nighttime FFMC. And then in this case, firefighting action now need to account for increased nighttime fire activity. So just as thank you to the University of Alberta, the Canadian Forest Service, Alberta Agriculture and Forestry, and Canada Wildfire.